Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Are we okay with the voice? Are we okay with the voice?
Yes, Mr.
And the screen is appearing for everyone? Okay. So we are going to start directly today's problem, in which we are going to check and experience solving a rectangular isolated foundation. In the previous classes, we have taken or we have completed square isolated foundation. We have learned what's the meaning of or when to calculate for bending moment. What is the meaning of one-way shear? What is the meaning of two-way shear? And we have checked for all of these as well. Okay. Now in this particular problem, we are going to experience something a bit similar, but the only thing that the form, rather than being a square, we are going to have it as a rectangle. Okay. Now the slide is there. Okay, the slides are there, containing all the steps, but we are going to solve it directly in the whiteboard. So you will hopefully understand it a bit more. Okay. So the first thing that we need to do is to check for durability. In which we can say that we are going to adopt a cover of 50 mm. Okay, so that's the first point that we need to do. After we are going to do that, we are going to start calculating the loading. Okay, so my loading, we said there are two types of loading. One is whatever we call it as service loading, or whatever we called it as SLS. And then we have another one, whatever we called it as ultimate loading, and we called it as ULS. Now for the service limit state, we said we are going to take the dead loads and live loads without taking into account the factor of safety. So here we have, in this particular problem, we have been given that the dead load is 800, the live load is 600. So what we are going to do, we are going to say that it is going to be 800 plus 600. Okay, that is going to be 1,400 plus there is a self weight, so in which we can say that it is going to be 1.1 into 1,400. Okay, which will be around 1,540 kilonewton. So my service loading, which will be used for the calculation of area, is 1,540. And then my ultimate loading, which will be used for bending an area of reinforcement, is going to be 1.4, which is a factor of safety of the dead, 800 plus 1.6 multiplied by 600. And we said while calculating for bending, we don't take into account the self weight, because the self weight has been already there before the bending occurs. Okay, can you give me the value here, or shall I calculate it? Can you give me the value here? Okay, so we have our value to be 2,080 kilonewton. Okay, so we had two values, one which will be used one which will be used for the area, another one which will be used for the bending area of reinforcement and shear. Now, after we finish from the loading, we are going to go for our area. Okay, we are going to go for our area of footing. Now, when it comes to the area of the footing, if we read the question, you will see that we need to design an isolated rectangular footing. Now, in this problem, the type of footing has been given for you, and then it says for you that you need to support an interior column, which is 40 centimeter into 40 centimeter in cross section. What is the meaning? What is the meaning of interior column? So I have a rectangular foundation. This is case A. This is case B. If your column is acting here, for example, and this is your 0.4 and 2.4, and then you have the other scenario where your column is acting somewhere in the middle, and this is your 0.4. Case number A is an isolated rectangular foundation with an external or exterior column. The column is acting on one side or one edge. It's an external or exterior column. Case number B, the column is inside the foundation, not in an edge, so we call it as an internal or interior column. Are we clear about A and B? Are we fine about A and B? Okay. They have given us another thing when it comes to the problem. Okay, let us read the problem better. So it says design a rectangular isolated footing to support an interior column, which is 40 centimeter into 40 centimeter in cross section. This foundation is to carry a dead load of 800 kilonewton and an imposed load or a life load of 600 kilonewton. We need to use an FCU of 40 MBA megapascals and then FY 460 megapascals. Say bearing capacity to be taken as 200 kilonewton per meter square. Footing overall depth can be taken as 600, so the depth of the footing has been given for us. Space limitations are such that one lateral dimension cannot exceed 3 meters. So we have one of the dimensions to be 3 meters. Which dimension we will see. Okay. Now we agree that this is going to be more of case number B rather than case number A because we have an interior column. Now area of the footing or foundation can be calculated as, if you remember, as a surface loading divided by your say bearing capacity, in which my surface loading was calculated as 1,540 kilonewton. Okay, so I'm bringing 1,540 kilonewton, and then my safe bearing capacity is 200 kilonewton per meter square. Kilonewton will go with kilonewton, meter square will go up. So we are going to have a value of around 7.7. Can you correct me here? Okay. We are going to get a value which is around 7.7. Okay. Now we know that our area is a multiplication. If it's a rectangle, it's a multiplication of width into length. Or let's say dimension number 1 multiplied by dimension number 2. Okay. Now we know that our area is equal to 7.7. One of the dimensions has been given in the problem. One of the dimensions has been given in the problem that it should not exceed 3 meters. So that's the maximum to be taken for one dimension. So 3. We need to calculate the other dimension. So my other dimension is going to equal to 7.7 divided by 3, and this is going to give you around 2.57. Okay, 2.57. We said we cannot have 2.57 when it comes to a site. So what we are going to do, we are going to adopt a foundation of 2.6 meter into 3 meter. So this is going to be the foundation that we are going to adopt. Okay, this is going to be the foundation that we are going to adopt. After we have checked for the durability, the loading, the area of the footing, the next step is to give for calculation of pressure. Okay, and then we can say that soil pressure is equal to your ultimate loading let us say that this is ultimate soil pressure. It is going to be your ultimate loading divided by your area of foundation, in which my ultimate loading has been calculated, or my ULS has been calculated as 2080 kilonewton. So now we have 2080 kilonewton. Area of the foundation, we have got it to be 2.6 multiplied by 3 meter, okay, which will give me eventually a certain value of pressure in kilonewton per meter square. And this value is how much? Okay, so let us say 266.67. Okay, so this is going to be my ultimate pressure. Okay, are we okay till now? Any question till now? Okay, so next step, I'm going to combine them. So we are going to have bending, one-way shear, and two-way shear. Okay. Now what we understood that we have a rectangular foundation. Okay. Okay. So now you can see, for example, now this is going to be my 3 meters. Well, let me use another color. Okay, this is going to be my 3 meters, and this is going to be my 2.6 meter. The first two, I'm going to use them for bending. The second two, I'm going to use them for one-way shear. And then the last two, I'm going to use them for two-way shear. Okay. And we have our column here, which is 0.4 into 0.4 for all the scenarios. Now we know that when it comes to bending, in bending, the maximum bending moment occurs. If we draw the bending moment diagram, the maximum bending moment, we said it occurs at the face of the column. Okay, this is in the first direction. The same goes in the other direction. So what we need to do, okay, we need to calculate the distance from the face of the column to the edge of the foundation. Let us call this one to be L2, and let us call the other side as well. Okay, where we are going to calculate from the face of the column till the edge of the foundation, and we are going to call this one to be our L1. Now, can you tell me how much is your L1 and how much is your L2? You have your dimensions of the foundation with you. Can we know how much is L1 and how much is L2? Yes. How much is L1 and how much is L2? So for bending, okay, we can see that L1 is going to be equals to 2.6 minus 0.4 divided by 2. Okay, so that's L1. Okay, L1 is 2.6 minus 0.4 divided by 2, which will give you 1.1 meter. Okay, and L2 is going to give you 3 meters minus 0.4 divided by 2. So my L2 is going to give me 1.3 meter. Okay. Is it clear why I have calculated two values of L? If you see, this is one portion of bending moment. This is another portion of bending moment. Okay. Now, if we are going to, okay. Okay. Now, if we have our M values, okay, if we have our L values, sorry, not M, can we calculate the values of moment? Can I calculate M1 and M2? We know that the general M value for a cantilever is WL square over 2. And we know that there is a pressure from the bottom, from the soil, which will take my foundation up, which will bend my foundation up. So my bending moment is going to equal to my W, which is the pressure. So that is 266.67, because my pressure is going to go from the bottom to the top. Okay. So 266.67 multiplied by my length, my first length is 1.1 divided by 2, and this should be squared. The second moment is going to be 266.67 multiplied by 1.3 square divided by 2. Now, can you give me these values of moment? Okay, so the first one goes as 161.3. This is in kilonewton per meter. The second one goes as 225.3 kilonewton meter. Okay, now doing that, we have finished calculation of the bending moment cases. Okay, now the second scenario is to go and check for two-way, one-way shear and then two-way shear. Now one-way shear is going to happen after a distance of how much? One-way shear is going to be happening after a distance of how much? After a distance of d. After a distance of d. If you remember, we had taken a section in which we said the loading is going to be transferred in this manner, and this distance from here to here is whatever we refer as d. Since we have a very huge loading going down here, a pressure going up, you can see that this particular location is very hard to be taken up because of the presence of the loading of the column. The load which will go up is going to be either this portion or this portion, okay, which is the distance after the value of d. Now, if we are going to take a distance of d from here, okay, a distance of d, and we want to know how much is going to be this particular length, can you help me doing that? Can we get the value of L1 here? Can we get the value of L1? How much is your L1 value? You can see that L1 value, half of the foundation is going to go as, okay, half of the foundation is going to go as 1.5 minus half of the column, which is 0.4 divided by 2, minus the value of d average. Now, how much is going to be our d average? D average can be calculated, let's say, in point number 6. Okay, or let me just have it a little bit far because we might be requiring some calculation. Let me keep it here. Now my D capital has been given in the problem. My D capital has been given in the problem to be 600 mm. We have dx to be calculated and we have dy to be calculated. We said D capital is the full depth, dx is going to be till the reinforcement of x, till the center of reinforcement of x, and then we have dy till the center of reinforcement of y. So this is D capital, this is dx, and this is dy. Now you can see the difference between dx and D capital is the fact that you are removing half of the bar and you are removing your cover. Okay, so I would go and say my effective depth is going to equal as 600 mm, which is the full depth, minus my cover, which is 50, minus my diameter, and then here I have assumed it to be 20, just to verify our results with the solved value. Once again, 20 is not a fixed value. We can start from 12. Okay. So how much this will give you? How much this will give you? I think it will give you around 540 mm. Okay, now going for dy. Now you can see if we zoomed between these two, you will see that the difference between dy and dx is this value, which is half of bar of x and then half of bar of y. Now if they are the same diameter, and normally they are going to be the same diameter, half plus half is going to equal to 1. So I can say that my dy is equals to my dx minus 20 mm, which is going to be 540 minus 20. This is going to go as 520. And we said we are going to use something called D average, in which we are going to get the average of 540, okay, plus 520 divided by 2, which will give you 530 mm. Okay, so we have got our D average. Now returning back to our calculation here. Okay, so my L1, according to the diagrams given, it is 1.5 minus 0.4 minus 0.4 divided by 2 minus the average. So I can say that it's 1.5 minus 0.2 minus 0.53. How much is going to be your L1? How much is the value of L1? The value of L1 is 0.77 meter. Okay. What about the value of L2? The value of L2 for the second shape, once again, now we are going to take the opposite direction. So we are going to take D from here, and then we are going to check how much is going to be this particular length. And the same thing goes for the other side. Now for you, left and right is going to be the same values because you are having your column at the center. If your column is not at the center, you will not be having the same values. Okay, can you give me now the value of L2? Can you give me the value of L2? This value of L2, how much is it? And you know that this is 2.6 meter. Okay. So you can see that this is going to equal as 1.3, which is half of the foundation, minus once again 0.4 divided by 2, because the other side is 0.4 minus 0.53. So L2 in this scenario equals to 0.57. Okay. Any question till now in terms of calculation of length number 1, length number 2? Any question regarding the calculation of these values? Okay. Let us call this one to be number 6. Since you will be calculating the average first, let us consider this is number 6, and this is going to be number 5. Okay. Now, after we have checked for one way, after we have checked for or calculated the length for one-way shear, we need to calculate our area of reinforcement, or we need to calculate the shear force and then the affected area of shear. Okay. Now, if we want to take these particular cases where for one-way shear, we have two cases. Let us say that this is case number called A1, and we have another case which is called as A2. This is for one-way shear. So this is going to be my, where did it go? So this is my area number, let's say area number 1, and this is going to be my area number 2. Now can you tell me area number 1 is equal to what exactly? Area number 1 is equal to what exactly? What are the dimensions for A1? How much is this? And how much is this? Can you give me the area of A1? Remember that we have already calculated length number 1. So your length number 1, this is 0.77 as you said, and then the length here is going to equal to 2.6. Okay, so 2.6 in one side, 0.77 in the other side. Okay, so I'll just go for A1, okay, where it is 0.77 and then 2.6 here. So my area or my affected area 1 equals to 2.6 multiplied 2.6 multiplied by 0.77, and this is going to go as 2.002 meters square. Okay. Now we will go for checking for A1. Now if we are going for A1, this is going to be your A1. We said that this particular dimension is 0.57, if you remember, This dimension now is going to be 3 meter. So this area is going to be 0.57 multiplied by 3 meter. Okay, so we have 0.57 here, and then 3 meter here. Values are not a problem. The most important thing that you should understand from where these are coming. So effective area number 2 is equal to 3 multiplied by 0.57, which will equal to 1.71 meters square. Okay. Now, after we calculated the affected area, and we know that this is the area, we know that this is the area which will be taken up from this diagram. We said that this is the area which will be taken up by the force. We need to know how much force is required to take this particular area. Now, what is the load which will take this particular portion up? Okay, which load will take this particular portion up? Is it the pressure or is it the loading of the column? What is the loading which will take your portion up? Which loading is going to go from down to up? And which loading is going from top to bottom? What is the loading which is going from the bottom to the top? There are two loadings you have. One is the loading from the column, which is going to go as from the top to the bottom, and there is another loading which is the soil pressure, which will go from the bottom to the top. It will cut my foundation. Okay, so the force which needs to be taken into account is my pressure, and the pressure is shown in kilonewton per meter square, if you remember. We know that the shear force is calculated normally in kilonewton. So I need to go use this particular pressure, which is in kilonewton per meter square, to go and calculate my shear force, which is in kilonewton. Now, in order to convert or change from kilonewton per meter square to shear force, which is in kilonewton, I need to multiply by what exactly? You will see that I need to multiply by meter square or an area. Okay, so if I'm telling you that we have this amount of loading per area, okay, so for example 10 kilonewton per meter square, and I told you my area is 2 into 1, then the loading required is going to be 10 kilonewton per meter square multiplied by 2 into 1, which is the actual area will be affected. That is affected. Okay, so in our scenario, there are two areas which are affected. There is A1 and there is A2. And we need to calculate our shear force. So now we can say that shear force or V1 is equal in this scenario pressure, because it's the loading which is going from the bottom to the top, which will cut my foundation, okay, multiplied by the affected area 1. So in this scenario, we have 266.67 multiplied by 2.002. Can you give me this value? This is going to be 521.87 kilonewton. So my V number 1, we have got it to be 521.87. What about the shear force number 2? What about V2? V2 is going to be equals to pressure multiplied by your affected area number 2, which is going to be 266.67 multiplied by your area, which is 1.71. This is going to go as how much? Yeah, I think it's 400 and something. 456 point. Okay, we have it 500. Okay, can you just make sure of the values, please? Because you are the one who is having the calculator. 266.67 multiplied by 2.02. This is going to be giving you 533. In the exams, be careful. One value will change everything for you. Okay, so we have got our V1 and we have got our V2. So now we know what is our shear force. Okay, we know what is our shear force. We need to go for the last step, in which we are going to calculate something called shear stress number 1, which is equal to V divided by area, which is equals to the shear force divided by the cut area. Okay, so my V1 is equal to, my shear force for case number 1 is 533.87. So 533.87 multiplied by 10 to the power of 3. V2 is going to equals to 456.0057 multiplied by 10 to the power of 3. Okay, to convert it from kilonewton to Newton. Now we need to know what is the cut area. Now to go for the cut area, we will go for the diagrams. We'll check. Now you will see, for me to take area number 1 out, I need to cut this particular dimension fully. So the first dimension that I need to cut is going to be 2.6. Okay, so we have it to be 2.6, and as well I need to cut for the whole depth. Okay, in order for me to go outside, I need to cut for 2.6, and then I need to cut for the full depth. Okay, so you can see the two dimensions that I have used are 2.6. Okay, or let us have it in millimeter directly. So 2600, 2.6 is 2600 multiplied by 530 mm. Okay, which will give you your value of V1. Now going for V2, once again we need to check what is the cut area for V2. I'm going to go for my second shape. Now for the second shape, in order for me to take area 2 out, I need to cut for this particular length. And this particular length is going to go as 3. So the first dimension to be taken into account is 3000. Second dimension to be taken into account is the depth. We need to cut for the full depth once again in order for my portion to go outside, if you remember. So it is going to be 530. Now can you give me how much is your V2? How much is your V2? And how much is your V1? So V1 is going to be 533.87 multiplied by 1000 divided by 2600 divided by 530. This will give me as 0.387. Let's say 4 Newton per millimeter square. The second one is 456.0057 multiplied by 1000 divided by 3000 divided by 530, which will give you 0.2868 Newton per millimeter square. Now you can check that we have finished. Okay, we have finished calculation of one-way shear. Okay, we have finished calculation of bending moment. We have finished calculation of one-way shear. Remaining is going to be the calculation of two-way shear. Now, two-way shear will be happening after a distance of how much? Two-way shear will be happening after a distance of how much? After a distance of 1.5d. So what we need to do, we need to take 1.5d from here. I need to take 1.5d from here, 1.5d from here, 1.5d from here. Now, if we do that, we are going to have two areas, if you remember. Okay, we are going to have two areas, if you remember. One is whatever we called it as interior area, and one we called it as exterior area, or internal and external. So we have two areas. Okay. Now, can you help me first? Can you help me in finding out how much is this value? Can you help me in finding out how much is this A? You can see that A is equals to 1.5D plus 1.5D, because we have 1.5D from here, 1.5D from here, and we have 0.4 from here. So it is 3D plus 0.4. Okay, which is going to be 3 multiplied by 0.53 plus 0.4. How much is this value? So 3 multiplied by 0.53 plus 0.4 is going to give you 1.99 meter. That's your A value. What about your B value? What about your B value? Once again, my B value is 1.5D plus 1.5D plus the column, which is 400 as well. So in this scenario, my A and my B are the same. Now, in which scenario your A and B will not be the same? In which scenario your A and B are not going to be the same? If it's a rectangular column. If it's a rectangular column, this is not going to be the same values, or these are not going to be the same values. So your A and your B are going to be different values. Okay, anyhow, here we have it as 1.99, and here we have it as 1.99 as well. Okay, and we know that this is 3 meters. This is my 2.6 meter. Okay, can you give me how much is the inner area? What is your inner area? Your inner area is 1.99 square. Okay, what about the outer area? My outer area will be total area minus inner area. So that is going to be 3 multiplied by 2.6 minus 1.99 square. Can you give me this value, please? Okay, whatever, 3.8399, 3.84 does not matter. Okay. Now, can you tell me which area will go down and which area will go up? The inner area will go down or will it go up? The inner area, which is having the location of the column, supposed to be going down or going up? It will go down. What about the remaining area? Remaining area, either it will stay in its position or it will go up. Okay. Remaining area or the outer area is going to go up. The location or the area where the column is available or the inner area, it will go down. Okay. So can you tell me which area will go up? We said it is the outer area, right? Now, how much force is required to push this particular area going up? What is the force required? What is the shear force required to put this particular area going up? We said which forces are going to take you up? Is it the pressure or is it the column loading? Which ones? Pressure. So pressure, what is the unit of pressure? Unit of pressure, once again, in kilonewton per meter square. Shear force in kilonewton. Okay, shear force is in kilonewton. So I need to multiply it by an area, which is in meter square. Which area is the area that is supposed to be going up? So my pressure is going to be 266.67 multiplied by my area, which is 3.8399. Can you give me this value of shear force? $1,023.986 kilonewton. Now this is the shear force. Can we calculate? Can we go and calculate our V small or shear stress, which is V divided by A, or shear force divided by cut area. That is equal to 1023.986 into 10 to the power of 3, since it's kilonewton. Cut area, what is your cut area? Okay, what is your cut area? How many dimensions you need to cut? You will see that I need to cut, in order for me to take the outer area outside, I need to cut this dimension first, second dimension, third dimension, fourth dimension. It is like I'm trying to cut this length, which is 1.99, into the depth, which is 0.53. This is going to be the first portion where my knife should go through, and then we have the same as the second point, same as the third point, same as the fourth point. So now what we have 4 times of 1990 multiplied by 530. Now can you give me how much is your shear stress for 2A? So we have it as 0.2427 Newton per millimeter square. Okay, we have it as 0.2427 Newton per millimeter square. Okay. Now if you see the secret that you need to understand in order to solve isolated foundation problem is that you should understand the drawings. If you understood the drawings, you will understand from where you will measure the dimensions, where to cut and what to cut. If you understood the drawings, you should be able to identify these values of dimensions, and then you will be able to calculate for one-way shear or two-way shear or bending even. Okay. Now remaining steps will be involving the calculation of area of reinforcement. Now you have the value of moment. You will be going to calculate the value of K, the value of Z, the value of AS. The same thing you will go for shear force, for shear stresses. Now we calculated one-way and two-way shear, and these are acting as the loading, which are caused because of the loading. And then we have another shear stress, which is the capacity of the concrete. Okay, which is the capacity of concrete. And you can see at that time whether you require to add additional depth or not. If your concrete shear strength is strong enough to take these two values of 0.2427 for two-way and 0.3874, because in one way we have two values, you will take or you will check for the highest, of course. So 0.3874 and then 0.2427 for the two-way. You will check them against the VC of the concrete. Okay, you will check them against the VC of the concrete. Let us see the presentation and then we'll go and calculate the VC. Maybe yes, maybe not. Expect anything in your exam. Okay. It might be a certain small portion, it might be something big. It depends on how many marks for that particular question and what is the time allotted for it. Okay. If you can see here once again, this is the problem. And by the way, I think you should know that there is no navigation. It means you cannot return back. And if there is no navigation in the exam, it means that whenever you are going to have a numerical problem and you need to upload before going to the other question. If you didn't upload, it is gone. You cannot return back to it. Okay. So for durability, we have a grade of concrete, which is given as 40. The cover, we have said we assumed it to be 50 mm. Loadings, we calculated service limit state value. We calculated service limit state with the self weight. We calculated as well the ultimate limit state values without taking into account the self-weight. And then we started calculating the area of foundation, and you can see that we have used the same steps. Okay, this is for the area of the foundation. And then calculation of the depth. So we have dx and dy. So we have got 540, 520, and then we have got the average to be 530 mm. And then we calculated the pressure. We have got our pressure to be 266.67. Critical dimensions. Okay, the critical dimensions, we have two values. Others, aren't you able to see the screen? Others, are you able to see the screen? Yes, no, no, yes, yes. Okay. No, yes. I think those who cannot see, they are having a network issue. Yes. It's a very weird thing. Okay. Anyhow, we have got the value. I'm showing only the calculation in terms of the PowerPoint that we have done in the whiteboard itself. Okay. So we have m value, which is WL square over 2 for the first length, and calculation of K, calculation of K for the other direction. So one time we have taken 1.3, one time we have taken 1.2. These are the values of L. Those who cannot see the presentation, it means that there is a problem with your network, because it cannot be half of the class seeing it and half of the class are unable to see it. If everyone is unable to see it, it means yes, there is a problem. It is stucking. Okay. Now can you check? Okay. So whatever I was showing you is the same that we have done in terms of calculation. Okay. So we have our calculation, the same things that we have done. Okay. We said we calculated two values of L. One is 1.1, another one is 1.3. So one time we have taken it for 1.3. Another time we have taken it for 1.1, and these are the values of moment that we have got. Now, after finding the values of moment, of course, you will go and find the values of K for the first moment, values of K for the second moment, finding the values of Z1 and Z2. That I think I shouldn't repeat. I don't think you will be having a problem in calculation of K, Z, and AS, which you have done for a lot of semesters already. Do you want me to explain for you K and Z AS calculation once again? Okay. So you have K, Z. Now you have two values of length. It means that you have two values of moment. It means that you will be having two Ks, you will be having two Zs, and then two AS at the end. So we have one AS here. We have got the first value to be 1025 for the length of 1.3. And then for the length of 1.1, we have got it to be 734. So the required, once again, the required for the 1.3 length direction, 1025. For the other direction of 1.1, we have it as 734, which cannot be taken. We will take the minimum because the minimum is 780. So we have two values of reinforcement. In one direction, it's 1025 as required. The other one, 780 as required. Now, if we go to our codes, okay, if we go to our codes, to the last page of the code, okay, you can see here, if we are using 20 mm diameter, if I'm using 20 mm diameter, okay, the lowest spacing, okay, or the maximum spacing here available is 300. So if I'm using 300, then my area of reinforcement is going to be 1050. Okay, if I'm using 300 mm, then it is going to be 150 or 1050 mm square. Now this 1050 mm square, is it sufficient for 1025 and 780? Is it more than 1025 and then 780? This 1050 mm square, is it sufficient, or is it more than 1025 and 780? Yes. Okay. So what we are going to be concluding here, we are going to be concluding that we need to provide T20 at T20 diameter at 300 mm spacing for both sides. Okay. So T20 at 300 mm for both sides for the 1.1 direction, for 1.3 direction. Since both of them are lesser than 1050, we are going to take 1050 mm square. Okay. Now in the previous problem, if you remember, we had one reinforcement in one direction, another reinforcement in the other direction. Okay. Or was it the same? I think it was the same. Okay, it was the same. Now in this problem as well, we had it the same. But if there is a variance, there is a big variance. Like for example, if this AS was 1100, if the first AS, for example, this one was 1100, you will see that 1050 is not going to be sufficient. Okay, so you will go for the next one, which is 1260 for the first reinforcement. For the second reinforcement, you will be taking 1050. Now, in this scenario, in this particular problem, we have 1025 and we have 780, in which 1050 is more than sufficient. Okay, that's related to the calculation of area of reinforcement. Now the last thing is to check for VC. Okay, let us return back to our, what is the equation of VC? What is the equation of VC? We will go to the code once again. Now in the code, we are going to search for shear. We are going to search for shear. So this is shear reinforcement requirements. We have shear stress, and then we have shear stress. This is not reinforcement once again, this is stress. So shear stress of concrete can be calculated using this equation. Okay, so we are going to take this particular equation. Okay, so we have our VC equals to 0.79 divided by 1.25, which is gamma m, multiplied by 100 AS provided, okay, divided by BD to the power of 1/3, multiplied by 400 and 400 divided by D to the power of 1/4. And then directly you can shortcut the other things, okay, by multiplying directly by FCU divided by 25 to the power of 1/3. If you remember, we said this particular portion is for the value of VC. And we said the value of VC should be modified if your grade of concrete is more than 25. So this is a modification now. I just multiplied everything in one equation. Okay, so we have 0.79 divided by 1.25, 100 multiplied by 1050, that's my AS provided. My width is 1000, my average depth is 530, multiplied by 400 divided by D. D is 530, multiplied by FCU, which is in this problem 40 divided by 25 to the power of 1/3. Can you give me each portion values? Can you give me 0.7 divided by 1.25? How much is it? I think this will go as 0.632. It will not change. Okay, the other one. Can you give me the values? Okay, can you give me the value which is inside? The value which is inside only. Okay, the value which is inside only. The value which is inside is 100 multiplied by 1050 divided by 1000 divided by 530. This will give you as 0.198. Be careful when you're doing your calculation. Now for this value, can you give me the full thing? Can you give me the full thing with the power? Can you give me the full thing with the power? Can you give me 400 divided by 530 to the power? Okay, with the power, right? Okay, so 0.932. Okay, and then can you give me 40 divided by 25? Okay, to the power of 1/3. Once again with the power, everything. One point 1696. Okay, no problem. Now, why I have told you in certain location with the power, certain locations without the power, we are going to see the code. You will see that the code says for you. Okay, the code says for you. Okay, the code says for you here, 100 AS over BD without the power should not be taken as greater than 3. Now this value of 100 AS over BD, is it more than or is it greater than 3? 0.198, is it greater than 3? 0.198, is it greater than 3? So we don't have a problem with it. This is fine because it's not greater. Now what about 400 divided by D to the power of 1/4? Now see, the first one is without the power, the second one is with the power. So 400 divided by D to the power of 1/4 should not be taken as lesser than 1. Okay, lesser than 1. Now, do we have it lesser than 1? Do we have this value lesser than 1? Is it possible to be taken as lesser than 1? Is it possible to be taken as lesser than 1? No. Okay, so what we need to do, this is to be cancelled, and instead of it, we are going to take the value of 1, because the minimum value is 1. You cannot go lesser than 1. Okay. So directly, in short, directly, if your depth is more than 400, keep this one to be 1. Yes, if it's greater, you will take 3. But it means that you are having a problem in your calculation. It will never reach to 3, because 3 means it's very heavily reinforced. Okay, now can you give me the value of 0.632 multiplied by 0.198 to the power of 1/3 multiplied by 1 multiplied by 1.1698. Can you give me this value, VC nu? My VC nu is 0.43 Newton per millimeter square. Okay, so this is going to be my VC nu. Now your VC nu, is it more than the V for two-way? V for two-way is 0.2427. Is it more? Which one is more, the concrete or the loading? The concrete is more or the loading is more? VC refers to the concrete. One-way and two-way refers to the loading. That's why you have taken loading into account. Now, if you see in the VC, there is nowhere you have included the loading into account. So VC is the capacity which can be taken by concrete without additional reinforcement. V two-way or V one-way is the shear force caused by the loading. Sorry. So you can see that the concrete is having more capacity. The concrete can take up to 0.43, but my loading is going to causing me only 0.2427. So in this scenario, this is going to be safe. The same thing goes for my V for one-way. My one-way, if you remember, we have calculated my V in case of one-way to be 0.3874. So 0.3874. Okay, which is lesser than the capacity of the concrete. Means the concrete can take it without any issues. Okay. Now doing that, we have finished today solving a rectangular problem. Rectangular isolated foundation problem. Now, one thing which I have explained for your other colleagues in the other section as well, which is related to the square and rectangle. Now, if we are having a square, this length equals to one length or equals to the other length. My area is equal to L into L, which is L square. So here we have only one unknown. Okay, we have one unknown. Means if you have your area, you can get your unknown dimension. In case of a rectangular, we have two dimensions. One is L, another one is B. And my area is equal to L into B, where we have now two unknowns. Now you will see in the problems that we have solved, one of the dimensions was always given to you. Okay, because there are two unknowns and you have only one equation, means you cannot go and solve for the other unknown. If there is one equation, means it will solve for you one unknown. That's why in this problem you have been given a 3-meter dimension. In the problem that we have solved, in the first problem that we have solved to check whether it's isolated or combined, once again another dimension has been given to you. Okay. Now what will you do what will you do if I'm having, for example, if I'm having, this is my column, this is like, let's say 450, and this is 200, okay, and I didn't give you in the problem any of the two dimensions. I didn't give you the length, I didn't give you the width, okay. What will you do? Because there are two unknowns. This is one equation which will solve for you one unknown. Now in this scenario, what you need to do, you need to use another equation, which is the ratio. So what we can say here, we say longer side of column divided by shorter side of column equals to the same ratio of the longer side of foundation to the shorter side of foundation. So now you can say that 450, or let's keep it 500 for the easy calculation now. So 500 divided by 200 should equals to length divided by width. So 2.5 is equal to length divided by width. So I can conclude saying that my length equals to 2.5 times my width. So now I have my second equation, which will help me here. Are we clear? Are we clear? If the dimensions are not given, what will you do? Once again, we are taking the ratios of the sides of the column to counteract the huge effect of the moment. Okay, doing that, we have finished today's session. If you have any question, then you are free to ask. If you don't have